As I've mentioned, our choice of data structures will profoundly affect how hard it is to implement an algorithm and will also affect its performance. So this being a data structures class, let's think about what data structures we might use for the encoding and decoding processes of the Huffman coding process. So let's say we want to encode from our original bit stream to the compressed bit stream. That is, I want to go from symbols to code words. What would be a natural data structure to use? So for example, if I have the letter I, then space, then ATE, I want to get back to the bit sequence 0000011001, etc. I think I messed up. Okay. So assuming the characters are of type character and the target bit sequences are of type bit sequence, what would we need to use? And what is bit sequence? It's just a class that represents a sequence of bits. So you don't need to know how exactly it works. Okay, so what data structure would we use to encode our data? So I'll give you a hint. It needs to be some kind of a map. Okay. So I'd say there's two pretty reasonable choices. One is to use something like a hash map or a tree map. So in this case, you would say, I want to map from character to bit sequence. And as you look up each character, you say get I or get space, and it returns you the bit sequence you need, and you write it out to the file. The other approach, which I think is arguably better, is instead of creating a map object, just make an array that goes from, well, it's effectively a map from each character to a bit sequence. The basic thinking here is that every character is, of course, just an integer. Like the letter A is the number 65. So if we have an array of bit sequences and we want to know what goes with A, we just go to the 65th entry of that array and get it back. So just keep in mind that an array is really a map from an integer to some kind of other object, and it could be a little more efficient. The difference is that with an array, when I want to get back the letter A, or sorry, the bit sequence going with the letter A, it's just a lookup. Whereas with a hash map, I would need to compute the hash code, mod by the number of buckets, look in some kind of linked list, so it'll just be a little slower. Or a tree map, similar. You'd have to traverse some kind of tree. So I'd say compared to hash maps or tree maps, arrays are going to be faster, but they'll use more memory if some characters in the alphabet are unused. So if, for example, in a Huffman code, if we're doing Unicode, we would need an array that is 33,000 entries long, and we would need to go, if most of the characters are never used, well, in that case, we're wasting a bunch of space. So I'd say both approaches are reasonable, though if you're only encoding ASCII text, I think arrays are arguably better, but either way is fine. All right, next question. Let's say we want to go the other way. We want to take the compressed bits, like 0000001, 1000100101, and get back I8. Now in particular, keep in mind that what we really want to do is get back the 8-bit, if we're using ASCII, bit stream, or sorry, sequence of bits for each character. So for example, A would be those 8 bits that go with A. So what would be the data structure we use to be able to go from these sequences of bits back to symbols? And I'll give you a hint in a moment, but give it a shot. Okay, my hint is there's some prefix operations here. All right, so it turns out the best choice, in my opinion, is a try. So a try, what do you mean? Well, in this case, the try would be a binary try. Its alphabet would be the numbers 0 and 1. So whereas before our tries had an alphabet that was like, A, B, C, D, E, F, whatever, and you have links for every possible letter, now we have 2 possible links for 0 and 1. And so for example, when we get this bit stream 10000111, what we're going to use is this decoding try, where I need to find out what is the longest prefix of this entire sequence. This is a bunch of text. This is all the characters in my entire file. So I will say, what is the longest prefix that exists in this try, right? So that's what I'll do is I'll just start stepping through and I'll say 1000. There, that's the character. It's the letter I, right? Okay, so now we've processed that much input. So now we use the longest prefix operation again, but now on all of this information. That's a little bit like autocomplete, but different, right? But same basic idea. So next we got to know which character is going to be the longest prefix of all of this? Well, the longest prefix would be 111, right? So we go there. All right, next is 1011. So we go 1011, and we get the letter A, and so forth. So just a repeated set of longest matching prefix calls, and we end up being able to decode our text and get back the letter A. So it turns out it's a trie, where the alphabet for the trie is zeros and ones. Pretty cool. All right, so just some thoughts about data structures. And basically with those two, you can actually go through and implement Huffman coding. We're not going to in this class, but you might find it interesting to do on your own.